Uh, Hello to whoever is watching this video. I'm recording this video as a part of task completion for Arogo AI internship. And here I was given two tasks. The first one is uh, ship delay prediction, in which we had a data set with these parameters, and we were asked to predict delay based on these parameters. In here, I actually wanted to point out something. Um, the dataset actually also contains uh, two, uh, two or three dates, like actual delivery date and the planned delivery date. I actually dropped the actual delivery date because in a real life scenario we would not know what is the actual delivery date before the delivery. But the whole point of machine learning is to predict the delivery, if it will be delayed or not. So that is why I've dropped actual delivery date. Initially I started training the model with the actual delivery date, and the scores were good. But when I dropped the actual delivery date, the scores kind of dropped, like the accuracy, precision, recall dropped. But I would like, but if we had the actual delivery date, then it would be much more simpler to use only a if else statement and check if the planned delivery date and actual delivery date are same. Then we could say that the delivery is not delayed. Yeah, else we could say that the delivery is delayed. And now let us uh, so I have performed all data preparation and this everything, and I have tried two algorithms or models. The first one is logistic regression, and second one is a random forest. Random forest gave me better results. Like I had around 94 percentage of accuracy. Like here, I mentioned them in the repository. Here we can see that we can see that we have a 94% accuracy, 98% precision, and so basically random forest was better at this task. uh, to perform or to replicate any of these tasks on your device, on your laptop, the first thing we have to do is uh, we have to clone the repository. So I am cloning my repository. Git clone, and this. So we have the repository clone, and the next step is, in order to run the first task, we need to go into um, we need to go into the cloned repository. It is named Arogo AI. So we will go into Arogo AI, and we have the folders logistic regression, random forest, task 2, and requirements.txt. So first we will install the requirements with this command. We can see that we have installed the requirements which are necessary, and now we can, to run the task, the first task, we can just go into one of the folders, logistic regression or random forest. I would go for random forest as it is performing better into by running the command cd random backslash forest, and we are into random forest. And now we want to run app lg2.py. We'll run python app lg2.py. This script will ask for the model path. The model path is available in files, so I'm just navigating to the files of a random forest in which we have the model and the label encoders that were used while training. So I'm just copying the path from here and I'll paste it here. Similarly, it will prompt for label encoder path and will perform the similar action for that too, and the script will exit. Now we need to run a command that is uvcon app lg2 app reload. This will start the API onto your local machine. As we can see that we need the model path, so we'll be giving it once again. So we are using random forest, so I'm giving the random forest file and label encoder similarly. So yeah, now we can see that it is up and running. So we can now go to this URL. This is your local machine's URL at port 8000, and this will take you to the Swagger UI, and we are here. So here we can click on try it out, and you can enter any of the values you want in here as per the dataset, not the values which are outside the dataset. Jaipur, and I'll enter vehicle type as truck, probably truck. The distance is something around 1170 kilometers, or weather conditions we'll keep it as clear, and traffic conditions as moderate. Shipment date, you can give any shipment date 0910. Planned delivery date 0915, and we can say execute. So we would be getting a response in here. It says delayed with the confidence of 1 or 100 percentage. We could try out some other option. Suppose we say it is not clear, we say it is storm, and it is light traffic, and we say execute, and we get delayed. Okay, so we could keep it as clear, and probably we could decrease this planned delivery date, and probably we should see it as on time. Yeah, so it predicts as on time with a confidence of 79 percentage. So this prediction is using random forest model to predict, and this is the explanation for the first task. For the second task, uh, we can similarly do follow the steps given in here. As we have already cloned the repo, um I'll be closing this. So as we have already cloned the repo, we will be directly running the steps from there. So let me quickly change the directory. So we now need to go to task 2. So we are going into task 2. So we are into task 2 now. App.py and app_ui.py are two files present in here. App.py deals with the backend API, where the blip model is running, and app_ui.py is the front end built on Streamlit. So we need to run both of these files on different terminals, so that they don't kill each other, and the execution runs smoothly without any errors. So I am running the first app.py backend API. So it is built on Flask, and so we can see that it will launch. So we can see it is launching on this. We can this on this server we can run our predictions. I mean, we cannot run our predictions, like we can post to the API to get our predictions. So I'm opening a new terminal, and again I'll just uh, change the directory. So we will run the front end ui.py. This will prompt you to run Streamlit command. Streamlit run app_ui.py. Upon running this, it will take you to the server, and here probably will search for some dog image, and we could take any one of the image and just give it to this. And if we click on generate description, so it will take some time, and we can see that we got the description of whatever is in the image: a dog running with a path in its owner with its owner. So this is about the explanation for how to run the second task using the GitHub repo.